enabling technologies for in vitro diagnostics. And under this title, I want to give a kind of overview of the research ongoing and also previously performed at the biotechnology unit at the Department of Life Technologies at University of Turku. And as we are part of InFLAMES, so I also would like to sort of, I wish that this talk creates some thoughts of how we could collaborate more closely within InFLAMES also. So during whole the history of this unit of biotechnology, which reaches back to about 30 years already. So the focus of the research have always been in vitro diagnostics, and especially in the main interest have been to develop assay concepts which are suitable for point-of-care diagnostics, or more generally assay concepts which are easy to use. And these assays are typically based on some sort of biomolecular recognition. So we have, for example, an antibody recognizing an analyte or biomarker in a sample, and another antibody labeled antibody detecting for the detection. Or in the case of the nucleic acids, we have a probe or primer hybridizing to the target sequence. And to develop such assays, or the strategy of the department, the unit has been to bring under the same roof basically all the key technologies which are required for development such assay concepts. So we have research related to the biorecognition tools like recombinant antibodies. We have research related to the high-performing reporter technologies, mostly like light-emitting sensitive reporter molecules. And then we are also focusing on various innovative platforms and exploring possibilities of different diagnostic platforms in these settings. And of course, in the diagnostics assay, key element is also the biomarker and the analytes, and that's also one area we are focusing on. And over the years, we have studied many different biomarkers related to many disease or other diagnostics areas. And when studying the biomarkers, we are mostly utilizing these technologies here, and in different stages of analyzing, maybe in the discovery of biomarker, or then in the validation of the biomarker at the early stage, or closer when it goes further in the clinical development. And I think it has turned out to be very good strategy to utilize these technologies from the very beginning. The same technologies basically which are utilized then in the final clinical applications also. So it helps the translation of the biomarker through this process, and for example, sort of helps to sort of guarantee that the biomarker is more likely to reach the final clinical application if it can be performed, if it's performed well in the very early characterization with these techniques as well. So a little bit more detail about these different technology areas. So first of all, the reporters. So we as said, we focus on the reporters, sort of light-emitting reporters with superior detectability properties. And something we have been dealing for a long time is lanthanide chelates, and we have an organic chemistry laboratory to produce these different type of chelate compounds, and these can be then utilized in time result fluorescence-based assays, which are pretty good to a pretty good concept to eliminate the background signal in the assay and increase the sensitivity of the assays that way. So we have these chelates have been utilized in different type of assay formats and or label reporter designs, and in our studies. Then another very interesting reporter concept, which is extensively utilized and studied in our department at the moment. So is this upconverting luminescent nanoparticles, which have very sort of good properties to be as a diagnostic label. So they basically allow complete elimination of the material background signaling, and that's due to this special property that they can be excited at the higher wavelength than where the emission and the detection happens. So it means that all the material background signal comes from the very high wavelength and does not disturb the detection of the signal from the assay. Then other technology area we are pretty active is the engineered bioaffinity reagents. So we are dealing with recombinant antibodies and some other recombinant binder molecules. So we have established a quite extensive toolbox to develop, engineer, and characterize these molecules. So we have different display techniques like phage display, mammalian cell display, highly efficient mutagenesis techniques, next generation sequencing based high throughput sort of screening techniques, and also some instruments to characterize the properties of these binders. And we want to create antibodies for many different purposes, and we do this without immunizing any animals. So we utilize synthetic antibody libraries or binder libraries. For example, our single chain FV fragment-based antibody libraries have been already used for generation of binders, more than 350 different targets, including small molecules, proteins, and many different type of compounds. We have recently established a library based on these DARBINs or ankyrin repeat proteins, and we are late phase of finalizing our new FAP library also. Combining these libraries with the display techniques, we can produce binders in a very systematic way. For example, to target very specific epitopes in the target molecule, or making binders, for example, which recognize the interface of two molecules, and very sort of unique binders can be generated with these techniques. We can produce the binders in different formats, and we can also further modify them, for example, for site-specific labeling, or combining them to make bispecific binders, or modify them for sort of controlled immobilization. Then a little bit about the platforms and assay concepts. So I think the conventional microtiter plate assay still plays a very essential role in our studies, and many applications are based on that. But recently we have paid quite much attention to the lateral flow type assays, and try to improve those or bring some new properties to those. We have explored potential of different label reporter molecules in these assays, and in order to convert them to in the quantitative detection format, and also we are exploring possibilities to introduce some additional functions to those, maybe additional washing steps and such in this type of simple assays. We have also experience of working with some microfluidics concepts, and there are also some dry reagent assay concepts developed in our laboratories. And in addition to that, there are various other more advanced assay concepts, which I don't think I have time to touch these in more detail, but so many different options. And I put here a picture of a 3D printer, which is a pretty important tool for us nowadays to produce like bits and pieces to construct such a assay setups and explore different solutions like sort of quickly. All right, here I have 3 examples of the assays where those technologies have been utilized. So the first here on this side, I think there is a assay to detect malaria pathogens in asymptomatic malaria carriers. And so this is a lateral flow based assay using these upconverting nanoparticles as a label, and it's a quantitative assay. And due to these labels, this assay is significantly more sensitive than traditional lateral flow assay, and really enables the detection of these asymptomatic malaria carriers, which is essential. It's essential to have a simple tool to detect those. If one wants to sort of meet the ambitious goals of WHO to eradicate this disease from the world in one day. Then the other example is a super sensitive cardiac troponin I immunoassay, also based on these upconverting nanoparticles. And so this assay, it was just recently published, and it's equally sensitive as the so-called digital ELISA assays, and performed for the same analyte. And it's generally considered that the digital ELISA assays are the kind of most sensitive immunoassay technique available at the moment. And however, digital ELISA is very complicated, and whereas this assay is simple, performed in a standard microtiter wells, and easy and convenient to use. And the third assay is based on the recombinant antibodies, which have been developed for the detection of small peptide toxins produced by cyanobacteria, which are blooming in the summertime in the Baltic Sea, for example, and in the lakes in Finland and causing and many other places. And these small peptide toxins, so it's a family of toxins including tens of different molecules. And this single assay based on two antibodies, it can detect basically all these molecules and in a very sensitive manner and also quantitative manner in the microtiter well based assay. And then there is also a lateral flow based concept which has been actually commercialized also. So based on these examples which I showed, I think we can provide some certain services, I think, to the companies and also other collaborators to hopefully to help them to develop the diagnostic concepts. So these such services and collaborations could include, for example, or could include the development and optimization of the reagents for the assays, binders and reporters and this type of important tools used in the assays. Then we can also help in the development of the actual assays and optimization of the assays and validations of the assays. And also I think we have, hopefully we could contribute also to the development of some completely new assay platforms or assay concepts if there is interest to develop such. I listed here a potential way to collaborate between academia and industry. So there are we can provide research services. There can be company funded, direct company funded projects or some co-funded projects with some governmental governmental funding agencies supporting, like Business Finland. InFLAMES can also support some academy industry collaborative projects. And something which is maybe would like to mention here is this relatively new concept, at least at the University of Turku, industrial PhD concept. So where the PhD thesis is basically supervised as a sort of joint venture by university and the industry. And then we have lots of students being educated as experts in the diagnostics, and many of them are eager to perform their master thesis projects in industry. So we are happy to obtain topics or proposals of the topics from the industrial partners. And something what we have done previously, so we have had many different collaborative and service projects with many industrial partners from Finland, and also international companies or companies from abroad. We have a number of technology transfer cases where the technologies have been transferred to the industry, and also 4 companies have been started based on the research done at our department. Yes, I will stop here and thank you for your attention.